I now have the great pleasure of introducing Professor Dame Jane Francis. Jane is no stranger to Adelaide. I think for 5 years during the 1990s you were a postdoc associate with Larry at the University of Adelaide. You are director of the British Antarctic Survey, um, and that's a research arm of the UK Natural Environment Research Council. Jane is involved with international polar organisations such as the Antarctic Treaty and the European Polar Board. She's on several advisory boards on national polar programmes. A geologist by training, with research interests particularly, I think, in past climate change. Jane has undertaken numerous research projects using fossils to determine the change from greenhouse to icehouse climates in the polar regions over the last 100 million years. She's undertaken over 15 scientific expeditions to the Arctic and Antarctica in search of fossil forests and information about climates in the past. Importantly, she was appointed Dame Commander of the Order of St. Michael and St. George, DCMG. And that was in recognition of services to UK polar science and diplomacy. She was awarded the UK Polar Medal by Her Majesty the Queen. She has also received the Royal Geographical Society's Patrons Medal, the 2022 Prince Albert II of Monaco's Foundation Award for Planetary Health. Jane is Chancellor of the University of Leeds and a Fellow of the Royal Society. It's my great privilege, Jane, to invite you to perhaps talk about the scientific impact and to launch this great bulletin. Thank you.
Thank you very much. I'm delighted to be here to see Larry and Neville again. As it was said, I came here from the UK in 1986 for 5 years to work with Larry, to go and study Cretaceous in Central Australia, and I had no idea what I was letting myself in for. Larry just rang me up one day and said, I've got some fossil wood, would you like to come and work on fossil wood, which was my expertise. And that began this story. And so that was 5 years of going and looking really mainly at the Bulldog Shale. We did go to Northern Flinders, but it was mainly the Bulldog Shale, wasn't it? And we went out into the field many, many times in the 80s, which was a very different story from how you've worked through this bulletin, because at that time we had no GPS, we had no maps, we had a scrappy old aerial photo, and we got lost most of the time. But it was great fun, and I'm absolutely delighted that now Neville and Steve have put together that huge volume, which I can't get in my suitcase because it's so heavy, but I've got a copy. But it's absolutely fantastic, and I have to really, really say that this is the beginning of it's a really important global project. So it's not just about South Australia, it really is about the Cretaceous across the whole planet and the implications it has for climate and climate change in the future. So Neville asked me to give a talk about Antarctica and how it related to this work, because Australia at that time was in the high latitudes, and it's about a story in the early Cretaceous about ice and being close to the pole. And so I'm just going to talk about Antarctica and the work that I've done, which also links to this. A slightly different time period, but it's a link, and it's going to take that volume, I hope, a little bit further in the future. So I thought about whether or not I could talk about things I've seen in Antarctica today, which is here's a satellite image of Antarctica, and about whether I've seen any features that Neville and Steve have written about in Northern Flinders. And the answer is no, because the problem is Antarctica is covered by this massive ice sheet, over 4 kilometres thick in places. And so anything that's going on glaciologically is covered by its own ice sheet. And working on the Cretaceous in Antarctica is a bit tricky, because most of probably what the Cretaceous story is buried underneath the ice sheet. So the ice sheet has buried the Cretaceous history. And we only know a little bit about the Cretaceous from around the margins and the Antarctic Peninsula, that bit that sticks up towards Chile. Thank you. And So the Cretaceous really won't be revealed until we melt the ice sheet, which is, we're doing a good job of going that way now. But there is the same story that Neville and Steve have, but in the latest Cretaceous in Antarctica. And I was looking at it yesterday, and it's incredibly similar. So I'm just going to give you a fast trip through Antarctica. So when I went, at the end of, when was it, 91, I returned back to the UK and I started giving talks about Cretaceous ice in the early Cretaceous. And everybody in the UK absolutely shot me down. And they said, you can't possibly be correct because the Cretaceous has always been warm. And they absolutely refused to believe there was any cold in Antarctica, in the Cretaceous. And so what I did then, and I was able to get grants to work on the Cretaceous of Antarctica, but had to do it from a different perspective and look at the vegetation in Antarctica to prove that it was always warm. And the idea was, and I was able to sell it to grant funders by saying this may be something that we will, the place that we're going to in the future, Antarctica, will be covered in forests again. But we did sneak in some work about the cold. So this is, the really crucial thing is, of course, the paleogeography. So this is one of the many paleogeography maps that does no justice to Antarctica. But the really key thing is that 100 million years ago, Antarctica moved over the South Pole, and it's more or less been in its position where it has been for the last 100 million years. And so when we see a change in the paleoclimate evidence in Antarctica from 100 million years to today, it is a climate change, not just a tectonic and paleoclimate change. And of course, Australia was still attached or very close to Antarctica at that time. And so the history is quite similar. And if you go to Antarctica today, you can see it's great fun working in Antarctica. It's a bit like working in the Eromanga Basin, in that there's rocks exposed, there's no grass, there's no buildings. Nowadays in Antarctica, we have very good support. I think working in the Eromanga Basin was the hardest field work I've done and the wildest field work I've done, because, you know, we had punctures, we had hot water, we had lack of fuel and snakes and other things. In Antarctica, there's nothing venomous that can hurt you. It's only the cold, and there's plenty of support like research ships and helicopters. So here's a picture of the late Cretaceous sedimentary sequence in some of the islands. And you can just, it does actually remind me a bit of Central Australia. It's badland topography on this particular island called Seymour Island. It's unconsolidated silt. If you dig down about 1/2 meter, you hit steel rock because it's permafrost, so you can't dig big pits. And it blows around in the wind, like the Sahara Desert when on a windy day. And just like the Eromanga Basin, you start at one end and you just measure the section across there. You may see a little orange mark at the top. That's our camp up there about 10 miles away. So huge distances of Cretaceous sediment, unconsolidated, containing fossils. And these fossils, that sequence is a marine sequence, it's a back arc basin sequence, a basinal sequence a bit like the Bulldog Shale. It has a nice fauna in it, marine fauna. So there's bivalves, there's gastropods, there's ammonites. There are gastropods with original shell material, so people have been able to do oxygen isotope analysis to work out that the waters were at times warm. And I have worked all the way through my research with an artist called Bob Nichols. And he takes the images that we have out of our brain and puts them on a canvas. So here is the marine environment of Antarctica in the latest Cretaceous, about 70 million years ago. So here's the sea. In the background, you can see what we think were the mountains with the forests on. And in the ocean, we've got these big creatures. The big one here is a mosasaur, about the size, I usually say, of a double-decker bus, but whatever the equivalent of a double-decker bus is in Adelaide. eating a primitive shark. You can see ammonites in the ocean, plesiosaur down here. You can see a shark eating a land dinosaur that has drifted out. We find the bones of land dinosaurs in here. In this ocean muds, we will have had all those ammonites and shelly faunas. We've got seabird fossils and a really rich fauna in the Cretaceous seas. When we were painting this, the artist said, where is the tree line? So I said, I have no idea. Put it halfway up, and then we can work through the fossil evidence in due course to work it out. And he said, how high are the mountains? So I said, I have no idea, and no geologist could tell me. So we made them as high as the Andes, and we put snow caps on them, because that's very likely to have happened at that high altitude. But that's something that we need to work out from evidence in the future. So that is a marine sequence, but in that sequence there are also fossil plants, which is what I worked on. So we have beautiful leaves that I've had students working on, and fossil wood, which is petrified and has beautiful tree rings in it, so we did climate analysis of those. We've got fossil leaves again, and also unbelievably good pollen that you'd be really jealous of, because all we had to do was put the sediment in a bucket, swirl it around, and all these beautiful polymorphs just popped out. So it was fantastic. So we had several projects in which we worked on the fossil plants and the sediments and worked out what the climate was like, and we're still doing that now, so we've still got papers that are due to be published. So in terms of the plants we have, you can see a really nice fossils, very similar to, here's one, a fossil tree fern from Antarctica, very similar to tree ferns that live in Tasmania, New Zealand today. I won't show you the whole lot, just a couple, but monkey puzzle trees, Araucaria, Araucana, beautiful, beautiful preservation in nodules, very similar to the Araucaria forests, monkey puzzle forests that you see in the high mountains of Chile amongst the, in the volcanic district. Very, very similar. And so we put together, again, working with our artist, Bob Nichols, a picture of Antarctic forests 100 million years ago. And this is based on work of several geologists, but also a PhD student who worked on flat layers of rock strata in which there were in situ tree stumps and rooted plants and leaves. So this is a really accurate representation of the forest. She measured the distance of the spacing of the trees and the positions of all the fossil plants. So we've got here ginkgo trees, which I'm sure you've seen, southern hemisphere podocarps, monkey puzzle trees, tree ferns, normal ferns, some plants in the undergrowth which went extinct, so we base those on reconstruction of the fossils, some bryophytes and mosses here in the undergrowth. But we didn't have any animals, so for the youngsters in the audience, this is a challenge for you. So we didn't find any animals or bones in these forests, and I asked the artist if he would just draw a couple of eyes poking out of the undergrowth, because I'm sure there must have been animals living here in this really lush forest. And when he brought this picture to me, which is now sitting in the British Antarctic Survey, I said, I was really disappointed. Where are the animals, Rob? And he said, I have put you an animal in there. It's something that you as geologists have got to go out and find. Can you see the animal? Where is it? It's behind the tree. There you go. Look, there's a dinosaur. He put the dinosaur, it's camouflaged behind the tree. Now, the interesting story about this is there are lots of these types of dinosaurs have been found in Victoria, in Australia, herds of them. So we've got them in Antarctica. We actually find the bones of them a bit further north. And we have found bones of this dinosaur, which is a sort of herbivorous vegetarian dinosaur about 3 meters long that snuffled in the undergrowth and ate all the plants. So we have a pretty good picture of Antarctica 100 million years ago. And if you go into the late Cretaceous and just look at the plants, we find other leaves. This is southern beech, Proteaceae, and then some Brachychiton, all plants that grow today in the southern hemisphere vegetation. So basically what we had in Antarctica was the ancestors of southern hemisphere vegetation. And here's another reconstruction by another artist for 70 million years ago, the late Cretaceous. So we've got monkey puzzle trees up in the highlands. We've got southern beech, funny looking southern beech, mainly in the lowlands. We have some red flowers here, which are the Proteaceae, which we find pollen and leaves of. We find flowers, we find gunnera, we find a lot of heathland plants from the palynology. So we have a pretty good picture of what the vegetation was like in Antarctica in the late Cretaceous. And then US and American and Argentine colleagues have reconstructed the dinosaur populations that lived here, non-avian dinosaurs which eventually evolved to birds, some real proper ducks in the Maastrichtian, and a whole range of particularly sauropods, these big lumbering vegetarian dinosaurs in Antarctica. So we have a pretty good picture of what was happening in Antarctica, but over, the Cretaceous, which is 100 million years worth of time. And since 100 million years now, of course, we've been through very, very warm phases. We've been through a glaciation. So we would expect some climate variation. So while we were working through all this sediment, and I was looking for the warm story to justify getting funding, we were also looking out for ice. So this is the kind of landscape that we were working on Seymour Island. We worked on exactly the same way that Neville and Steve have been working. We had 1,200 meters of silty clays and clay silts. It was the most boring, monotonous sequence of rocks I've ever seen. More boring than the Bulldog Shale, actually. And just laminated, and here we are collecting palynological samples. We only ever had to use a shovel because we didn't ever have anything hard enough to hit with a hammer, except when we dug pits, and then we had to leave them to melt a little bit overnight and then come back to collect samples. And it's taken many years, actually, to date them and to look at the palynology. And then we were able to put these complicated diagrams together that was also in the book. But what we did find was we did stick our necks out, and we said that there is evidence for late Cretaceous ice in that sequence. So although you have forests, we also had ice, and we had evidence for sea ice. Now, if you say that in the Northern Hemisphere, amongst the geological community, we would consider heretical, but we managed to get it published, and so we managed to say there was evidence for late Cretaceous ice in Antarctica. And then the climate modelers came along, and they modeled the late Cretaceous for us, and they were able to generate ice caps on the center of Antarctica, and maybe a little bit on our mountains on the peninsula for that time. So although it's high CO2, they even with 2 times carbon dioxide present day, they were able to generate ice caps in Antarctica in the climate models. But you can see what they generated was ice caps on the center of Antarctica that really didn't spread, according to the models, to the margins where we would find the signal of Cretaceous ice in present-day sediments. So anyway, we thought that they were there, that it's been published, and this is what we think Antarctica looked like, probably, or the Antarctic Peninsula looked like in the late Cretaceous, and this may have been what Australia looked like in the early Cretaceous as well, and maybe even in the late Cretaceous. So maybe you need to do some more field work, Neville, to go and look at the late Cretaceous. So forested lowlands, lots of southern beech, lots of the southern hemisphere vegetation, but at high altitude maybe there was glaciers, snow on the mountains. What we found in Antarctica is evidence for sea ice, we think, as well. So I've put some sea ice on our picture, and I put in here the quote that Neville has in the first volume of the of the Bulletin, in science there are no universal truths, just views of the world that have yet to be shown to be false. And I think that sums up really well the argument that we have to make certainly in the groups, the Cretaceous groups in the Northern Hemisphere that I work with, in that they think, well, you know, what's the evidence? It's so hard to pin down evidence for ice in the fossil record and in the geological record, unless you actually have proper glacial deposits. So what that bulletin does is actually really prove that there was ice in the early Cretaceous in Australia. And in Antarctica, of course, I think we had ice on the Earth. If there's land at the poles in the past, I think there is a very good chance that there is an ice cap, certainly on Antarctica, when there are high mountains there, and that generated sea ice and cold temperatures over the South Pole. There was nothing in the North Pole, no land over the North Pole. So what happened was Antarctica got actually, after the Cretaceous, got very warm for a time during the Eocene, and then it cooled down, and then the ice sheets started forming about 34 million years ago, and then you get the Antarctica that we see today, and about 5 million years ago it spread across the whole continent. So the Cretaceous story is really important in the whole history of how Antarctica became glaciated. And I think we need to really go back now and try and understand that actually the world with a continent over the pole was not hugely warm, that there is potential for ice, particularly in the Cretaceous, which does have huge implications for global sea levels of the past and our understanding of climate change in the future. And I think the Bulletin is now, for me, a next step. I think we need to do a review of the Cretaceous and write a paper which says the Cretaceous was cold and only at certain times was it warm enough for forests to grow in the southern regions. So it's a fantastic achievement. I'm absolutely delighted that there's brilliant evidence now for ice in Central Australia, and that the Cretaceous story can really come together in the future. So well done for the Bulletin, Neville and Steve. It's just a fantastic piece of work. And thank you, Larry, for starting it off. Thank you very much.